Hello everyone, my name is Lana and I'm from Team 12827, the Crazy Cat Ladies. I'm here to tell you about early season prototyping and brainstorming. Early season brainstorming is one of the most critical parts of the season, as it shapes what your robot is going to look like. Once your team watches this year's game animation, they will probably have tons of ideas on how to solve the challenge. Ultimately, though, you will compete with just one robot that includes the ideas and designs that you choose to incorporate. Whether you have lots of ideas or are struggling to come up with any, your goal is to come up with the best ideas that you can. Like I said, sometimes great ideas don't just appear, but creativity and engineering knowledge are tools that will help you create ideas. Once those ideas are in place, you will want to know that they will actually work in the real-world environment. Prototyping will help show you which ideas work as you imagined them, so that then you can move forward with those successful ideas. We call this the diamond, a visual illustration that represents the process our team uses when generating ideas. The idea is pretty simple. On the left at the skinny point, you don't have any ideas. As you come up with lots of ideas of all types, you now have a large assortment of ideas to choose from. At that point, you can narrow down your ideas to find the ones that will best be successful. We don't try to eliminate any ideas until we've generated a lot of them. It's actually pretty crippling to creativity to try and find the best idea from the beginning. We'll talk about how you generate and narrow down those ideas in just a minute. So, how do you come up with lots of ideas? Well, as your team brainstorms, remember, the more ideas, the better. We are big fans of sticky notes, though index cards work too. Basically, grab a big stack for each team member and ask them to write down as many ideas as they can. It's important to remember at this point not to get bogged down by the details. What motor will work? Do you have the right part in your inventory? Those are considerations for later. Right now, you want to get all of those ideas in your head onto paper. At this point, it's also important to remember that regardless of each team member's specialty, you should get input from everyone on the team. The different ways team members think allows for a great diversity of ideas. We start by having our team members write down their ideas individually first. Often, when you hear ideas from others, it can shut down imagination or make people shy and reluctant to share. It's really important to support and encourage each other. There is no such thing as a bad idea when you're brainstorming. Now that those ideas are on paper, it's time to build on them. At this point, you could write down your favorite idea, then pass the paper to a teammate on your right. Once everyone has a piece of paper with someone else's idea on it, they try to add to it or improve it. This is especially helpful to get everyone talking if they are reluctant to share their ideas. At this point, you'll have lots of ideas, so next, break into small groups to collaborate, because you're more likely to get more discussion in smaller groups. Throughout this process, you haven't gotten rid of any ideas, so at the end of this brainstorming, everyone should have heard everyone else's ideas. Now you can start to select ideas. Remember those details I mentioned earlier? Motors and parts inventory? Now it's time to add those constraints along with other properties for the robot, game elements, and the field as explained in the game manual. Among other things, your robot cannot be larger than 18 by 18 by 18 inches, can use a maximum of 8 motors, game elements have specific dimensions, and throwing is sometimes allowed and other times prohibited in various seasons. All of these factors and many others will need to be considered in order to evaluate the viability of your ideas. It's a good idea to draw simple sketches of your plans and do simple calculations like torque to test for basic viability. Plus, these are excellent documentation for your engineering portfolio. As you consider that long or heavy arms require lots of torque, and a holonomic drive only leaves 4 remaining motors, for example, these factors will help you steer towards particular solutions. You will likely have lots of sketches and calculations at this point, so you may discover that some ideas may begin to emerge that become your favorites. You can begin to withdraw ideas if everyone agrees on it, but expect to be surprised about how some ideas don't turn out as you expected when you put them to the test during prototyping. At this point, you'll be very glad that you have multiple other great ideas to fall back upon. Without a doubt, the best way to prove out an idea is through prototyping. A prototype is a very simple model of the part you intend to build. Prototyping allows ideas to compete against each other outside of your head. What I mean by this is, oftentimes things sound like a good idea, or might even look like a good idea on paper, but once you fabricate a very simple prototype, you can actually test them out. I also really recommend that your team use CAD modeling, as it can reveal design challenges that weren't already apparent. Even if you don't fully CAD your robot, using modeling for individual subsystems can be very helpful to avoid redesigns, which can be time-consuming and frustrating. By the way, if your team is new to CAD, I've created a series of videos for FTC students getting started. You can view them on my YouTube channel, which I will put in the Zoom chat box. So, when building prototypes, keep them as simple as possible when you first start out. Use disposable materials like cardboard and power them by hand or with a power drill. The idea is to see if your idea is effective in as little time as possible. You don't have to use your actual building materials to verify that a concept will bear out. Similarly, don't build prototypes on your chassis. We use test harnesses and also clamp prototypes onto tables to test them. This allows multiple people to be working on multiple things at once and avoids the situation where teammates are waiting for their turn to work on the robot. You can also be testing different prototypes at once to determine the winner. This shows a prototype from our Ultimate Goal robot last year. We used a conveyor belt system that pulled rings through the inside of the robot. Though the conveyor system had pulleys on both sides, we constructed a prototype on one side only, with no initial concern for powering, mounting, etc. We could determine that the pulleys could in fact grip the ring and that it was the right size to accommodate the ring. So that proved out our idea, and we went forward with the design. This final example shows a type of prototyping. We used stand-in materials until we were certain of the design. We wanted to do a holonomic drive with custom-printed metal panels last year, so we used inexpensive, easy-to-cut wood panels to verify that we were indeed set with that design. Custom panels are pricey, so we didn't want to have to remake them. As it turns out, with a remote season this year, damage to the robot from other teams on the field wasn't a consideration, so we kept the design but just used plexiglass panels instead. But it was great to be able to verify that the design worked before custom ordering any panels. Similarly, we needed a platform on the bottom of our launcher. Plexiglass is more of a pain than a big expense, so it's nice to just cut it once. While we were testing that the design in fact worked, we used poster board as a stand-in. In this case, we wound up switching to plexiglass shortly after testing. This slide shows a test harness that we used last year. As you can see, it's just made up of extrusion that is the same dimensions as the superstructure of the robot. It was sturdy enough to sit on the ground without us holding it as well. In this case, we were testing the ring magazine that we were building. You can tell from this photo that the magazine, under the ring, is in an initial 3D printing phase. We later went on to print a much thicker, more robust piece. In this case, we were able to verify that the magazine worked as we hoped and that it would fit in the space it needed to on the robot. There were times that we added multiple prototypes into the harness to verify that they performed well together and fit as they were supposed to. This slide shows a prototype of our launch guide rails from last season. You'll notice that part of this prototype is 3D printed. One thing your team will want to consider when 3D printing prototypes is to print using a lower infill setting or thinner walls. When you print a final version of a part, you'll likely want it to be sturdy and durable, so setting the printer to create such a part both uses a lot of filament and, more significantly early in the season, takes a lot of time. So, when you are printing a trial part, be certain that it's a quick print. Once we had this part printed, we mounted it to some channels that allowed us to quickly mount it along with the other part of the subassembly that worked in conjunction with it. In this case, the flywheel. Once you have verified that the prototype is viable, you can move on to a more sturdy print and work on assembling it on the robot. A word about subsystems. In general, before I go on. Last year, our launcher, which included a flywheel, was our particularly hard-working system. We did a lot of motor testing, speed testing, and launch testing off the robot. If you have a subsystem that you know needs extra attention, you could consider testing it independently of the rest of your robot to ensure that it performs like you imagine. So, to sum it all up, consider a diverse set of many ideas. Use details of the game and rules to select the best ideas possible. Prototype as quickly as possible ideas to see which ones actually work well. And finally, put the best performing designs onto your awesome robot. Thank you so much, and I hope you have a fantastic season.